Hello and welcome, guys. As you can see, this is a GATE 2020 Computer Science and IT um, question. This question is from binary search tree, which came last year. So we are going to solve this problem. How we are going to solve this problem? So first of all, as you can see, it is given that the pre-order traversal of a binary tree is given. The order in which we'll get the pre-order traversal of the tree is given. Which one of the following is the post order traversal of the tree? Now obviously there is a particular tree, okay, of about which we are talking. So if we traverse the tree in pre-order that is given in the question, now they are asking if we means just by looking at the pre-order traversal, can we tell the post order traversal? Yes, we can tell. First of all, I will tell you in due time. So now we have to tell, because see, we don't know the tree as of now. So first of all, we'll have to construct the tree, then we can then we'll be able to tell what is the post order traversal of the tree. So how to construct the tree? Now one thing which is not given in the question but that is known to us by default, that is the in order traversal. In order traversal of the tree. Now what is an in order traversal? In order traversal is always if we sort the numbers, if we sort the numbers in increasing order. So these are the numbers which are the nodes of the trees. Doesn't matter in which order it is in pre-order. The increasing order, if we arrange these numbers in increasing order, it will become the in order traversal of the particular tree we are talking about. As of now we don't know what is the tree. We'll construct it, then we'll be able to find the tree. So what is the lowest node? So let's sort the numbers in increasing order. Okay, 10, 11, 12, 16. Okay, sorry, 15 comes before. 15, 16, 10, 11, 12, 15, 16, 18, 19, 20. This is our in order traversal. We have the post order traversal. Now with the combination of these two traversals, we'll be able to find out the, I'm sorry, first of all we'll be able to construct the tree. How? Let us again go. So now pre-order, in pre-order what happens is, if I just let's say in this side I just write, okay, in pre-order what happens is we first print the node, then we go to the left node, then we go to the right node, isn't it? In order, we go to the left node first of all, then we print the node, and then we go to the right of the node. Okay, so if we see this particular order, then see any tree traversal, first of all, first point to note is that any tree traversal starts from the root node. So if we to do the pre-order traversal, if we start from the root node, let's say this is the tree, okay, this is the tree, let's say we don't know what is the tree now, let's say this is the tree. Now any traversal will start from the root, isn't it? This is the root, so any traversal will start from here, then we'll go to different paths. So for pre-order, we'll start from the root, and if we go through this algorithm, then we are going to print the x first. So what is the first x? First x is our root. So anyway, we are going to get the first, sorry, we are going to print the root first. So now we are very much clear that 15 is the root, because in the traversal we have printed, in pre-order traversal we have printed 15 first, okay. So 15 is the root, so we'll slowly start constructing the tree. 15 is the root. Now come to in order. This way I particularly solve the problem, and mostly I believe this is the in general method. So 15 is the root. Now see, if we go to in order, if this is 15, before 15 we have the left child of 15 and we have the right subtree. So the left subtree of 15, right subtree. So in this side, this is the, so just by looking at the picture we are very much clear that these all numbers are less than 15, these all numbers are greater than 15, and according to binary search tree configuration, all these numbers 10, 11 and 12 will come in this root, I mean in this portion in the left child, and 16, 18, 19 and 20 will come in the right. So similarly, if we go through this approach, then we'll be able to construct the whole tree. So now what next, what we'll do, 10, 11 and 12, among them which one will become the root of this subtree? We'll again find out by going there. So 10, 11 and 12, 10, 11 and 12, this is one subtree, this is another subtree. In this subtree, by preorders configuration or by preorders algorithm, first whichever is printed is the root. So 10 is the root, so 10 is the root. So now if we construct this, if we construct this, 15 was there, 10 is there. Now see, if we just follow this one, 10 doesn't have anything in the left side, but it has in the right side. That means in this tree 10 will not have any left child, it will only have right child. So in right side we have 11 and 12, there are two options. Okay, now we'll come to this subtree 16, 18, 19, 20. This is the subtree. Again we are looking at the pre-order, right? So in this subtree, we're looking at this subtree, we'll see that in the pre-order the first node of this subtree is 20. That means this is the root of this subtree. 20 is the root of this subtree. Now we'll come here, 20. 20 has 3 nodes in the left among this subtree. 20 has 3 nodes in the left but no nodes in the right. Means all this 16, 18 and 19 will be the left, I mean all will come in the left subtree of 20. 20 doesn't has anything in the right. Okay, now what we will do, among 10 and 12, see now we'll come to this one. Okay, this 10 and 12, so 10 and 12. Okay, so now we'll go to, sorry, 11 and 12, I'm sorry, 11 and 12. Among 11 and 12 again by pre-order, among this tree this is a subtree. Okay, this is a subtree of 10. So now we'll focus on this. 12 is the first node in this subtree according to pre-order algorithm. So the first node becomes the root node of that tree. So 12 becomes the root. Okay, so 12 becomes the root here. Okay, I'm just writing here, 12 becomes the root. Okay, now 12 does not has anything in the right, only in this tree. 12 has 11 in the left, so this portion is complete. Now we'll come to this portion, 16, 18, 19. 16, 18, 19, again by pre-order algorithm first node becomes the root node, so 18 becomes the root here. Okay, so in this one 18 becomes the root. Okay, so if 18 becomes the root, now see in this one 18 has 16 in the left, 19 in the right, so 16 as the left child, 19 as the right child. So the tree construction is complete. Are you getting it, guys? We were given pre-order traversal, we are given in order traversal. So based on the, just by having the knowledge of both the algorithms pre-order and in order, we are able to construct the tree. Similarly, if in the question post order was given and in order is given, again based on this two we would be able to find out, or we'll be able to construct the tree. Now once we are able to construct the tree, now we can easily run post order algorithm on this, and we'll be able to tell what is the, you know, what is the traversal. So now as we have constructed the tree, so now we will apply post order traversal on this tree and we'll see what the answer is. So for post order traversal, we have written the algorithm here in the right side. So X will recursively call the right child or right subtree, sorry, the left child or left subtree of x, then it will go to the right child or right subtree of x, and then it will print x. In this way, this function will execute. So let's start. So as we have recursive calls here, so we'll beforehand we'll just construct a stack here. Okay, this is the stack because stack is used in recursion. Okay, so now the traversal will start from the root node 15. Okay, so 15 function call for 15 is done, post order of 15. So 15 comes here. Okay, now what happens? Left of 15. Okay, there is a recursive call to left of 15, which is 10. 10 comes. For 10 we'll go to left of 10. There is no left of 10, so right of 10. So 12, so post order 12. So now for 12 again, left of 12, so 11, post order 11. 11 will come here. On 11, left of 11, there is nothing in the left of 11. Right of 11, there is nothing in the right of 11. Print 11. So we will print 11. The first node to get printed in post order traversal is 11. Okay, though by seeing the answer we see that there is only one option which starts with 11, so obviously B is the answer. So this is to save your time, but we'll go through the whole answer. So 11. Okay, so now 11 has completed the function executions. 11 is popped out. Control comes back to 12. So right of 12, there is nothing in the right of 12. Print 12. Print 12. For 12 also function execution is over. Pop it out. We're at 10 now. At 10, left of 10 there was nothing. We went to right of this, and we came here. So now we'll come to print of 10. So we'll print 10. Where is the end of the function for 10? So we'll pop 10. 15, we left at this line, left of 15. Now we'll come to right of 15, means 20, post order of 20. So 20 call is here. So now when we're at 20, left of 20 is 18. So there is a function call to 18. Okay. So now left of 18 is 16. So we come to 16. Left of 16 there is nothing. Right of 16 there is nothing. Print 16. End of 16, pop 16. We'll come to 18. For 18, there is right of 18, which is 19. Post order of 19. 19 comes in this call. Now for 19 there is nothing in the left, nothing in the right. So we'll print 19. Pop 19. 18. Left and right both are done. So we'll print 18. Pop 18. Because end of the function for 18. Control comes back to 12. For 12, left is already done because we've already covered this left child. There is nothing in the right. Print 20. 20's execution is done. Pop. Now we'll come to 15. For 15, left subtree we have already covered. Right subtree also we have covered all the nodes. So now these two are done. Print 15. Done. Execution is over. Function is complete. So this is the post order traversal of the tree. Thank you.